Hello, so today we are looking at Chapter 3, Section 3. And our essential question is written right here, and this is something you should get down into your INB. How can you find the sum, so when you add together, the interior angles and the exterior angles of polygons? We just did this with triangles. We looked at how the interior angles add together and equal 180. We looked at the exterior angles and how we can find an exterior angle by using the non-adjacent interior angles. But now we're going to do that with polygons. So shapes that are not just triangles, but have more sides. So let's work through this together. So we have this polygon right here in blue. And what it asks us to do here is write down what this polygon is and the number of sides that it has. So we're not going to get into naming polygons that much, but this has 1, 2, 3, 4 sides. So we can write that down in our number of sides here. So n equals 4. And when you have 4 sides, it's called a quadrilateral. Quad meaning 4. A quadrilateral. It's kind of silly that they gave you such a small space there. So what we're going to do now is draw a line segment, so a line, so that it divides this shape into 2 triangles. So let's do it. So I drew a line that separates this quadrilateral into 2 different triangles. The next question is there more than one way to do this, and explain. So when I'm looking at this, yes, there is another way to do this. I could choose the other 2 angles to connect. So that would look like this. So I could start at either angle. But they both form 2 different triangles. The triangles are different shapes, but they're 2 different triangles. So now we want to look at this question down here. What is the sum, so when you add them together, of the interior angle measures of each triangle? And this is something we just did in the last section, is we recalled that there is this rule that when you add up the interior angles of a triangle, it always adds to 180. So each one of those triangles has angles that add up to 180. So now we want to think about, okay, well, how does that help us figure out what is the sum of the interior angle measures of the figure? That's where I'm going to pause and let you think about this. I'll give you a few hints here, but just think about, we have information about 2 triangles. You know that this angle plus this angle plus this angle equals 180. And we know that this angle plus this angle plus this angle equals 180. All right, so now let's extend this reasoning a little more with these 4 shapes here. So we're going to work to look at the number of sides that these shapes have, and then how many triangles can be formed using the reasoning from these. So how many triangles can be formed by dividing shapes? And then what is the angle sum of those shapes? So let's take a look. So let's take B as our first example. And we're going to start at a corner here and count the number of sides of this shape. So 1, 2, 3, 4, 5. So B has 5 sides. Now let's check out C. 1, 2, 3, 4, 5, 6 sides. Continue that with D and E, and you'll find that D has 7 sides and E has 8 sides. All right. So now we know the number of sides here. And we want to think about if we divide these shapes into triangles, how many triangles can we make? So let's start with B first. Start at a corner and make our triangles here. So when you have a pentagon, you can divide that into 3 triangles. See what happens with our hexagon. Potentially seeing a pattern here. So pentagon divides into 3 triangles. Hexagon divides into 4 triangles. 1, 2, 3, 4. So let's try with the heptagon and octagon. All right, so that pattern seems to be continuing. For the heptagon, we have 1, 2, 3, 4, 5. For the octagon, we have 1, 2, 3, 4, 5, 6. So let's start filling in this table here. If we have a triangle, that's only 1 triangle. However, if we have a quadrilateral like we did in our last example, we can just go flip back really quick to see that, that can be divided into 2 triangles. And then as we just showed, you can divide that pentagon into 3, hexagon into 4, heptagon into 5, and octagon into 6 triangles. So what I'd like you to do here is take a minute, based on what you know about the interior angle measures of triangles, figure out what the sum of the angles inside each of these shapes will be. So I know that triangle is 180. And then because a quadrilateral, like we showed back here, has 2 triangles in it, those measures will add together to be 180 times 2. So following that pattern, fill in the rest of this table.